Hello YouTube, welcome back to my channel again. Today we are gonna learn about buffer overflow preparation, which is the I was finished the task 1 to task 3, and we got to finish the task 4 to task 11 overflow 10. This difficulty level is easy, so let's start from the easy start. What I gonna do is I want to connect to the machine. So first let's start the machine here. This room Windows OSGP buffer overflow uses the 32-bit Windows 7 VM. Let's open our terminal here. I'll open two terminal. This is for VPN connection. Okay, connect to the VPN. Should be on the machine. If I refresh, this access machine would be my IP. that's my IP is 10.4.27.160. I think the machine was up and 10.10.72.5. Copy this and let's I want to make it vertically and this is horizontally. Okay, I want to set up this on CD2. Let's zoom it out. Okay, I think it's closest thing is the if it's bigger here, can I split with the same size? Yes. Okay, let's move to our directory. Let's open our Visual Studio Code here. Some the code was I'm writing. Let's okay. So I was got the exploit.py and fusing.py and generate char.py. Okay, every this Python I was chmod this as a when pen is not here. Let's move this from this folder. Offset. Exploit offset is 0 and payload is 0. I was modified the payload with open the pattern here. So let's comment the pattern first because we start from the comment. This pattern will be overwriting. Let's remove the content here. And bed charge is actually 00. Okay, we are set up properly. And readme file here. SCP task 2. I think I must create the answer in here. Task 2 is what is the EIP of offset overflow 1? Answer is here. Let's move this. Let's format exploit creating pattern and Mona set config the Mona. Mona config. Let's grab this and put it here. I think let's move this and let's complete our lesson. Embed order overflow 1. The answer is this. How I got this before and you will know. On task 3, I think the same version here. We move to taskbar. Okay, let's start with the remote desktop here. I will clean my trash. Okay. Open the remote desktop and copy the IP here. And where's my remote desktop here? Come on. Okay, I will overflow this. I will modify the IP. So save, and we are connect to the machine with user is admin and password is password. Just continue. We have this on the machine here, a Windows 7 Professional, and let's set up our preparation here. First, the machine, we are gonna open the Ubuntu debugger here, and let's me to config the view here. I think in the option and appearance, and let's change the font to 9 maybe. Okay, and set okay. Is that mine? 9 is was looking good. Now we are open the mission on the desktop. Open the folder of vulnerable apps, osgp and osgp.exe. What do you think? You can read the maybe we are to up. Okay, font size here. Let's change to 12. What's thing? Okay, it's better for me. And we include the file, and this is still the pause here. And before we start, let's configure our Mona here, like our readme file here. Set config the Mona to the working directory here. Okay, copy. paste the command we will copy here and press enter. This will generate a Windows user and Mona on the C/Mona, and the other payload will be put on the Mona directory. We can see the folder here will be on drive C on the Mona folder. Where's Mona? Mona, where's you? Where are you go, Mona? The Mona has been here. Okay, let's try to run. It's just setting configuration for the Mona, and for see the CPU on the register. Let's open the CPUs here, main thread. We not need monologue data, and this is the AIP for writing. And let's take a look what the program is. The program will start like program was listening on the port lead 1337, and let's try to connect to the program and what kind of the program it is. Okay, let's and see the IP here. And port is lead 1337. Welcome to SGP vulnerable server. Enter help for help. Okay, unknown command. Let's use help. Valid option overflow 1, and then there's a space here. Okay, let's write the overflow. Unknown command overflow. Oh, this is overflow 1 space here, and then complete. Okay, and let's exit. Okay, where's I want to command the exit. You said the valid command here. I have the exit command here. Exit space. Hi. Let's clear that, and our start here is take a look the program connection closing and still run, and nothing happened here. And the first thing we're gonna do is fuzzying how much the command will be overflowed. So let's try to modify our pushing code here. We are now on the IP is not the exit IP here. Copy. IP, and we on the overflow tree. Okay, I will make the IP is good. Okay, let's close the readme file here, and okay, first we're gonna do is we'll fuzzying the server with the command overflow with let's take from 200 here, and this will increase the byte by 100, and looking for the making the application crash on how much length the payload will be making the application will crash. Okay, we will do the fuzzing here. Let's fuzzing the server here, and let's take a look. This will up the sending by 200 bytes, and we will see here the application is still running, and this connection and connecting, close it until the program is will crash. This will crash the program. This is was crashed the application here, so our fusing application will generate 1,300 bytes to send. This is our payload will generate, and run Mona after crash to find the offset. This is we will find the offset from the Mona. Just copy this. I think our payload will be I will change this to more middle. Okay, let's copy this and let's see our pattern will have the comment here. I was deleted this that again before, and this, and now that was added by the fuzzying comment I'm using to write the pattern here. I'm using pattern the Metasploit cyclic with the pound tools, and let's make our exploits too easy. Just paste the Mona here and find the I think no, not yet. We will start the let's open this debugger and restart again, because this is the IP is 41414141. If you want to know what is the 414141, is the that is the pattern that is char for 41. It's a char that's str char, isn't it? Is that 41 of the how to check that? Let's check the ordinary for a the bigger a is 64. How about a small 90? What's 414141? It look like the ASCII from the a here. So 414141 is the a for 4 times. I don't know. That's how to show you the a is the ASCII car. Okay, and 1023. Let's send the payload here to the server, and we will find at the this payload is 1300 bytes will be sent to the with the pattern here. We will get the 4141 here as on the this byte to make sure that it's under the 1300 to get the offset of the payload. And let's do it. Okay, that's clear. And okay, we start the server again. We will often start the server and check the application is running or pause. If it is that pause, then start it by running. the AIP was changed. Okay, so we're gonna try to send our payload here with the generated pattern, so our exploit to be open as generated payload. Okay, I'll open here and exploiting. Let's run the exploit and sending payload, so the application will be crashed and the IP here is the difference. That's the pattern that was we sent, AO like this. And let's find the pattern, and the Mona will tell us about the offset. You see, the offset is 634. Okay, we got 634. So if we generate it, let's write that. Let me exploit on the overflow. Oh no, this is the overflow tree here. Overflow 3, not the overflow 2. And let's rerun again. Okay, look, the ECX is 0 and ESP is not anything yet, and this is the register for the server the application uses, and this is the dump of the address. This is will use the msgtf.tll. Okay, application run and try to run our exploit again. Ta-da! And then let's find the 3721. Let's copy this, the AIP here, copy selection to the clipboard, and I will show you how to, that will be on the cyber safe maybe. How to find that as the hex binary maybe as a pattern. And let's paste that here from hex 5 key MBA. That will find on our pattern. On our pattern here, we will find the F, the paste, and why that's not be in our payload. Okay, just ask the Mona. Okay, our offset is 1274. Okay, I think the answer is the task for on the overflow 1230 1274. Okay, and try to submit that. Okay, now we got the offset here. Why we look for the offset? Because if we got the offset here, we can override the program, execute models, and we can modify the EIP here. What is the EIP? EIP is the instruction address where the application will be run. Okay, we can do this with the 42 by, we know the offset like this. let's run it. The IP is 77D1 and 70B4. Then on the exploit, I will write the offset here as 1274, and I will create the return address is BBBB. So and then if I run the exploit, so this AIP will be 42 42 42. Okay, let's try it. Exploit, and the application will crash, and this 42 42 42. Okay, and this is the next instruction, so we can write the instruction to the system, and we can exploit the application using that EIP to run our cell in the box. I'm sorry for my English very bad, so I hope you understand what I'm talking here. And let's start the application. So right now we will find the bit character on the application. With the setup, the bit application will be start in the 00/x00. That's null byte, so we remove the null byte on the pattern here, bit char. So we will move the null byte and generate the byte between 1 to all bytes here between 1 to 255 char. And let's do our exploit and run it. Okay, and right now we will generate our bit char here on the Mona. Let's run this. On the Mona, let's paste it here and run it. That will be same with our payload here. This one, all of this, and we can find it on the Mona folder here. Call it with the byte array. This is will same with our generated byte array. This is all of the byte array here, and it's the same with our generated byte array here. Actually, this, let's copy this to the our exploit. Let's modify our right. I will modify our generating bit chart to the like pushing here. We generated the pattern, but looks like we write the byte, I don't know. So the exploit is still open the pattern here. Let's paste our. Let me show you this. Copy this byte between 1 and 250 all chart in the application. That will be based on our payload here, and when we run the exploit, make sure our open is was common. And if we run the exploit, let's run our exploit in here. Make sure that our application was listening. Okay, close this, and then try to run the exploit here. Done. And then we got the 4242, and let's compare the beds to check what byte is the bed char. Okay. What the code Mona of to compare that bed char? This. I will try this. Copy this. Copy. And then put that to the Mona. Control V. It's the same. It's not the comparison. The comparison code will be let's open our readme here. To compare the Mona, we will need the ESP address here. Let's copy this and put this on the Mona. And the address is our ESP here. Let's double click on the ESP and copy this address and put this on here, and let Mona compare, and we got our bed character here. Let's copy this. Copy the clipboard is the bed char. Okay, all the bed character here we will gonna put on the bed char here. This Control and Control V. This is the bed char. Okay, so our bed char here can be affected with the next byte. So 00 is a bed char and the 11 is the bed char. This 11, the 11 here can affect to the next byte. So the next byte we will remove the next byte, and this one is the bed char, and this will affected, and this one a bed char, and this will be unaffected byte. This is a bed char, and this is will be the affected, and remove this. Okay, and save and run the generated byte again. Okay, then run this to Mona to create byte array comparison. Copy this and paste it here, and let's Mona generate this again. That will remove this byte bed chart disk from our application. Then close this and just restart the application. Start and run, and then copy this byte to our payload on exploit. Paste it here and try to run again, and the application will crash again, and we can run the last command. If we check the address, is the ESP address just look like was different here. Let's copy this address again. Let's paste it here, and this is copy and put it here again. Control V and then enter again. The Mona will compare, and if it's the unmodified, then there's nothing the bed chart here. Okay, and we can submit our bed character as the value for the question on the TryHackMe here and submit. Okay, and that was the correct answer. And let's there is my readme file here, and that is the answer here, and the offset is 1274. Next we will try to run. I will show you something. Let's create a reverse cell to the application. Okay, let me clear here, and I will remove my Kali box. And then generate our payload with MSF Venom min B, and I have the last comment, this one, this pattern create, and I want to create this. We will listen on port. Let's copy our bed chart here. And that's it here. On port 4444, okay. That's wheel 4444. Okay, let's generate our payload here. And let's listen here with the 44. This is the payload here. Let's copy this, and I will show you. I hope this will be good. We modify our payload with, let's remove this, payload equals to this. Okay, we have listed on port 444, and the application is still this, and try to start the application. So if the application run on the server and we run our exploit, what we have to do? Okay, let's run our exploit here, and we should get our listening here. Where is it? Oh, I think the application will crash, and this 4042 will be we will find the jump ESP. So the first thing we're gonna do is to jump ESP is jump ESP. We will find jump ESP with the comparison here. Let's copy this. With the bed chart, our bed chart is, let's check our bed chart here. There is our bed chart. The Mona. that will be here. We will find the jump address from the SP on the Mona. Let's paste it here, and let's check where's the Mona. Okay. Let's restart again. Run the application. So if we have our exploit here, let's copy this and do the last and save this and run the application with jump DSP. Okay, the application will be crash, and then exploit, then we check the address from the operation. So the log data, we got this address, the ASP here. Let's copy the address and paste it on here. So we will create this and paste it here, and then copy here, copy to clipboard or line, and paste it here. Message, that's a message. Where's the address? Where is the address? Oh no, let's copy. Where is the log file here? Windows on the log data. Jump ESP ASCII page to read. Now we will jump. Copy to clipboard the address and paste the address here. Okay, so we will put our address here as a return address with little endian. Little endian is we must separate byte by byte with a reverse. So the IP is will 03, so the byte will start from here, and 12/x50/x62. that will be our return address here. And let's copy the NOP address, no operation, with 16 maybe. And where is our payload? Where is our payload? Okay, this is our payload to get the reverse cell. Okay, let's copy this and modify our payload here. Start the offset here, and it is okay. Payload will be equals to this, and save all our credential here. And what we gonna do is restart the application and run it again, and let's see. So we are listed here at port 444, and we got to run the exploit, and we got the reverse cell here, you see. So we can remote the server here with the command in Windows, because of Windows, and we got the ESS function there, OSGP, and that's reversals buffer overflow used to. So and the running application, we can take the box to override and to get the cell back to us again. Okay, the application will crash here. The application will run. You see, this is running and the IP is good here. All application will run, and but we got our cell. The application generate a cell to the attacker, where we have a MSF Venom do here with the Windows reverse cell. Let's copy our exploit payload reverse cell here. I'll copy this on the bottom. Windows cell first 210.4.27.160. Okay, let's back again to our mission. Well, not here with nothing. Let's empty our node here, and let's set this again from 0, and we start to overflow 4 and fudging and overflow 4. Okay, like the mission before, we try to next our mission. Okay, now let's try to exit here and Ctrl C and clear our payload here, clear, and then our byte char will be removed. That's 00, no byte here, and let's move to the task 5. The task 5 here on the readme. Let's cut this was of the IP offset for overflow. Okay, the next is in the order byte, which is the overflow 4. Okay, let's try it again. First, we gonna restart here just to make sure all is good, and run it again. And the first thing we're gonna do is fuzzing the application. After we got the application stuck at what IP, clear our run here, and then we will set up our exploit to use payload, not to use payload here. Let's comment out this. So our payload will use this pattern, and okay, let's finish our. Okay, this is will crash here, and what our posing tell here. 2100. Okay, let's start again our debugger. Run it again. Okay, application running, so do the exploit and run the Mona. Find the offset. We got the offset here, 2026. Let's paste it to our 2026 and find the bed chart here. Find the bed chart. Let's start our mission. To find the bed chart, first we're gonna reset the bed array on the Mona folder. Might array bin here. It's all. Let's remove this. I think that will be generated bed array. Let's try to run our Mona to generate the payload from fuzing. Here's the Mona command here. Command distance to find here, and then run the exploit. We got the Mona here, and then what else? To find a bed chart. Okay, generate the bed chart, huh? / generate the bed chart and run the Mona here. Copy and let's paste it here and enter. And then application still run, and let's exploit again with our payload. Copy and modify our payload. Equals to this. Save and run it again, our exploit here, and actually we will compare. Do the Mona have this one? Yes, we will run it and compare to the ESP. Okay. Mona compare. Oh, this should not have. We set our payload here. OverFlow, and let's set it to BBB. And our exploit again. So the Mona, the application will crash. And we need to compare our bed array, generating bed array with compare in A with the address of the ESP here. And check the bed chart. Let's copy the bed chart. And paste it on our bed chart here. And remove the affected byte. And then let's generate our bed chart again. Run this on the Mona. /XR9 should be removed. /R9, okay, R7, okay, let's generate it, and then restart the application again and run it again, and make sure we run our exploit again, and check the Mona again. ESP here, copy the ESP, and run the last Mona command with the IP of here. And if we oops, the test box not Mona, why? X Unity debugger command Mona line compare name fc Mona is why? Instead our time was exceeded. No, we have still have the why we got the Mona here compare with let's restart the application. Try to exploit. Not connect. The application look like not running. Okay, sending payload and that array.bin 1abfr. Let's copy and Ctrl V and enter. Why? Immunity debugger bed chart is different. Comparing with memory location at 00 stack. Traceback last. I think our last bed chart is run save, open the bed source, and save. Why? Let's clean this Mona again. Delete. Yes. Let's start to create the Mona with 0 0. Okay. Clear. So we'll generate our payload, our bed char with Mona. I think bed char is me save here and clear. Let's generate bed char again. Generated bed array. Control V. Mona should be generated, and let's start the application and run it. Not is on the exploit here, should be 0. And our payload will be changed to this, and place it here and try to run the exploit again. Let's exploit. Okay, let's compare the Mona. I modified the generate bed char. Payload equals our payload here. And can I write some to the payload for bed char equals to open payload bed char .txt, and I will open it as write. What is text? And payload for bed write. Payload str payload. Let's try to run the generated. Okay, and let's check payload bed char. Okay, and I will modify the exploit here. Run the payload existing done. If let's modify it. Python check file if exists. how to check file if exists with the pattern is file. Is file. We need to import OS. Import OS. If os dot pet dot dot is file, to create is file to check pet. It's pet is the example. Dot slash payload underscore bed underscore char dot txt. Then our payload is here. Else payload equals to empty string. Let's copy this again and make it here. I want to print Mona comparison, so we just copy paste. Okay, Mona. Okay, can we do some exploit here? Make sure the application is run. Start and run, and I think our padding will be set to empty, and try to exploit Mona. Copy this Mona and generate this Memphis. Got the address, the ESP, and paste it here. And find the number to find reach Mona OSJ byte array. Oh, OSJP slash byte array. Okay, let's copy this. Let char and pay here. Payload bed chars. Delete the payload bed chars, and let's do it by one. Okay, I want to exploit. Our payloads here will be open. The file of this. And when I Mona is compare OSGP patch /b. Should I escape the slash here? make sure the application run. Restart, run again, and generate our vector and generate our exploit. Copy this bed array. Now we run a bed array here. Control V, enter, and then Mona will compare this bed array bin on the dump file. So this will check on the memory, so this will not work if we not re-exploit. Can I just run it? Copy, Ctrl I, Ctrl V. Just pay here and got the address of ESP. Copy. Wait, I think we have the exploit this on the wrong overflow 4 and buzzing is overflow 4. Okay. Okay. With this address. Okay, and fine. What we get is 02. 02 is a bed chart 2. Then let's gen our bed charts is with 02. Save it and generate again the bed chart, create the Mona again, embed array for Mona, and Y 0x0102. Okay, and start the application and antitrust. And then run the exploit again and copy this again. Paste it here with the address of and find the bed chart again. 03 is 2. Let's add it again to the 03 and I think 03 why is increased 1 by 1. Our expert is offset. Can I use we are on the right bed. BBB 2026, isn't it? Can I make sure the Mona have a restart? JavaScript, this is cool, bro. Thank you, bro. Just need to restart the application and restart and run, restart and run, restart and run using Unity debugger here. Our payload, let's run and read. Okay. Run the exploit. We need to generate our payload. So first we must add 03 here because the Mona said, oh wait, it's the bed choice. Let me try with the 00 again. Look like the bed charge here is need to override the I'll try to exploit if the ASP is writing, and then let's Mona generating the 00. I'll copy this. Mona will generate the 00 file, and after that let's run our exploit with the Mona compare and then see get the IP here, the ESP, and and what we get is 01 bed char here. Is this our exploit using BBB? Let's remove the BBB here to make sure if the bed char is different or not. Okay, and then run the exploit again, and let's compare the Mona again. Confirm with the address this ASCII. It's the same. It's 01. Okay, let's modify our bed charges to add the 01 and clear. Generate the bed char, and it's on the Mona, and restart the application, run again, and then let's exploit again, compare the Mona, with the ASP. We got 02, add a 02, generate again, and start again this mono. Restart and run and exploit. Wait, how we close the application on the exploit? We write on the file. Okay, open to read. Look like it doesn't need to close. Should I use payload to close here? No, this is read not write on the our gen file. How we close the application? Our payload bits are still open. Okay, this was generated with /02, and our mona is okay, and I want to show the log data. Nothing. Let's generate the mona, including 2-bit character, and run it again. Okay, and start it again. Try to exploit it again. Compare the mona with the address. Of this ESP. Can we just go Ctrl C here? F03. Why is this increasing by one by one? Not like before. Our exploit need to write the where our exploit, where is our exploit? All this I try to write it with the full address here and try to run it with exploit again, and try to check the mona again. I think that's the IP was different here. Wow, it's raining, rainy day, and looks like 03 is unmodified. Okay, corrupted. It's equals, never mind, with BBB or with nothing. Then let's write our bit chart with the 03 and run our payload again. I will use to command generated here and result run it again. Run the exploit again. Compare with the ASP. A13 04. Wow, this is increasing by 1 by 1. Corruption after 0 bytes. And I have the is the corrupted file. Why if I copy this and paste it on my exploit, look like payload equals to this, and I will copy this file and run exploit again. Looks like the same. Wait. Sending payload application is still Control P. The ESP is different. And enter. Yeah, this week we got a lot. Look like the we cannot read the file and we cannot write to the file, so I will start with the 00. I think I have something to read with the Python read the char here, so we cannot read the file. Just write the Mona on the exploit. I will try to let charge is on 00 and our exploit generate the char. Run the Mona first. Okay, restart the application. Exploit with the override and run the exploit. Compare the byte array. With this address, it should different. Nah, this is the right address here. Copy to bed char 04 R9 and entropy. This is a bed char. Let's modify our generate bed char here. Pattern close. Bed char close. I will not right click on the file and save this bed char. Look like 04. Let's remove the AA. The answer is too long. No, it's look like no. Just 4 byte character. Let's remove this with 02 remove, 04 remove, AA is removed, and remove on the wrong file. 00 is bed char, so 01 affected, 03, 04 is affected, 09 is affected, this will affected, this will affected. Let's generate again. Gen bed char, copy the mono, here, enter, back, restart, run, and copy. Look, copy, exploit. Run the exploit again. Compare the mono. With the address of the bed char is increased. Zero 2 is equals 04. 02 is exists. 02, 04, 04 it exists, isn't it? Still 04, then R9 is not a bed char. What? 05, 04, 06. Mm-hmm. 06 and CD. Okay. Search gen char, mono, Okay, enter, start, and copy, paste it on the exploit. Run the exploit. Compare the Mona. The address of this. And enter. Wow, the bed chart is increasing. Zero 060109 CD and CD4. How is the lag too so long? How we have the our payload is here. Offset. If we write this as BBB and run our exploit again, yes, we still got the same here. I'm afraid it's too long. The ESP is different. Trophy. I think this was the right. Look. Looks it's the different. Okay, the bed charge is CD. Spray. Use on the right bed. So let's add A9 with CD. Let's just with A9. Okay, let's generate again. Mona byte array again. This was too long, very long. The answer is look too long with the task. The task here just a few. This is for too long. This is long. This is too long. It's like too long. But on the overflow, 4. We need to add an hour again. What I miss here? What I miss here? What I miss here? Okay, let's just generate. Let's run with A9. Okay, stop and start again. Control C to our exploit. Control V to our exploit and run our exploit and see the Mona to compare again. With the address is different here. And we need a CD. Property clipper, better. And better. Control V. We need to add the CD here. Can we add the default too? I don't know what to make it. The bed chart. Why is increase one by one by one? Just do it. Just do it, just do it. We got the generate again. Write the payload. It was a long exploit here. Looks like this was different. This was too long with the answer. Let's try it for the last. Okay. And application is running and run the exploit. Compare the address. Wow. Oops, corrupting. Comparison one location, compare byte from file with memory. Stuck. Why it's stuck? Exploit. Okay, let's start from the zero. Then let's start. I will remove this from the 0 and the bed chart of the 0. Let's generate. Write this on the Mona bed array. Okay. Let's start and run it again. copy with our exploit. The payload is Spain, and run our exploit and compare the Mona with the address. Of the ESP. Copy. Look, the ESP is like this, moving. We got this. Oh no, oh no, oh no, oh no, oh no. The bed charge is not 1010 watts. That's so. Copy the bed charge and V here. We make sure the exploit is if we looking for the bed chart, we need to set the return address here. Okay, let's save it. Let's just add with this will effect and this remove. This will bed chart, this will effect, this will bed chart, this will effect. Okay, let's generate again bed chart and copy this as a bed array. Let's generate and stop the application, start again, run it again, and copy our payload here to our exploit. Let's stay here and run our exploit here. Compare the Mona here. Until we get the unmodified. Let's copy this. Now this look like the address is still correct. So we got the unmodified here. And I see now. Let's copy this bed chart as the answer. We got to have spend a lot of time on here. Let's paste it on the answer in here. And our readme here is 2026. Okay, let's clean again the exploit. Make sure we run the exploit for generating bed chart. This is not set, and this is try to set to 0, and I think I will remove this. I will show you, but if someone asks what to use this, I will use this. And pattern, find the pattern. Okay, this is will opening. To find a pattern, this will open. This will code, and let's move to OverFlow 5, and I will pushing to OverFlow 5. Okay, now we need to copy the task 6. We must be faster here. Let me, I will close this picture and generate picture, payload picture, and 6. This is the overflow 5. In byte order, what is the overflow? Well, okay. Try to using it and stop and try to debug again. Let's start again, and now we try to fusing there to try to find the EIP offset and try to fusing it 200 bytes, 300 bytes, and we have the distance here, and looks like our pattern was generated, and our exploit open to the pattern.txt and overflow 5, and okay, we need to restart again and run it again, and now we try to open a new tab here. Desktop, CSM, TryHackMe, buffer overflow here, and let's do exploit here, and after exploit find the Mona, entropy. What is the offset? Look like the 314. Let's move it here, 314, and let's set this to BBB, and let's copy this, and our picture will start from 00 again, and let's answer this with the 314, and right on our readme file here, the answer is 314, and now we need to restart and run it again. Now we need to generate our beta, run it on the Mona, make sure our exploit is set up properly with 300 and BBB, and our payload is this one. And let's paste it here, and let's run our exploit here and compare the byte array to find the byte char. And the EIP here, and we should find a byte char here. Copy to clipboard the byte char here, and modify our byte char. This is a byte char, and this is a byte char, and this will be affected by. This is a byte char, this will be affected by. This is a byte char, this will be affected by, and this is a byte char. Let's save it and generate the byte array again. Set the Mona to using this as a byte array, and then restart the application run it again, and let's copy our payload here, set on the exploit. And run the exploit, and compare the bad array generated with the IP here, and let's check unmodified. So we got the answer for the task is here. It's very quick. Yeah, actually this just for move to the next task. Let's move to the task 7, OverFlow 6. And we need to write this again. Write this again. And try to reset the application. Start again and reset our payload exploit in passing. We on OverFlow 6. We are on OverFlow 6 and save it. When the passing run, let's modify this offset to 0, and this offset to 0, this offset to save another pattern. After passing, we got how much? Okay, we got this, and let's debug and restart again. Run it again. After running, try to use exploit. After exploit, find the distance, gravities, or the mona, and find the byte 1033 and modify this to our exploit 1033, and it's 1033. Make sure this as answer, bad answer. Why my return address have this? So look like 2 byte here. It's a 2, isn't it? It's a 30. You broke the application. Start again. Run it again. Try it, exploit again. Copy this on the mono. What's the correct? 95 is the correct answer. What? Why? Internal pattern is offset 1. rank is ESP here. So this is the ESP, not the offset is 1. Are you sure? Let us start again and start the mission. Oh no, that's clear, and we are on overflow 6. Okay, in the fuzzing we are on the overflow 6, and try to start it from 100. No, it is 200. The fuzzing was still the application is stuck on it's different thing here. Okay, we got the stack here at the Mona. Okay, let's copy this 1100 bytes. So on our exploit, why using start from 200 and offset here is start from 0. Okay, and start our exploit. How will we restart the machine? No, go back and start the machine, run it again, try to exploit it again, and find the offset. $10.34. $10.34. Okay, we got the correct answer here, and let's 10.34. Now we find the bed chart. 10.34 and set the BBB and set the payload to open, and remove the bed chart, try from 0, and let's clear and do generate the bed chart right on Mona. Generate the bed chart. Mona was created, and start the application, run it, then copy this to our exploit, paste it here, make sure the BBB is correct, and then run our exploit, compare the Mona with the ASP address, the ASP is here, copy the selection, paste it there, and find, copy the bed address to the bed chart and put it on our bed chart here, and modify it. This is a bed chart, and this is affected byte, this is a bed chart, this is an affected byte, this is a bed chart, this is an affected byte. And let's generate again, run this Mona again, fast. Okay, and run it after wanna do it. Let's start the application, run it again, and copy the bind to our exploit. Save it and run the exploit, and copy this again, and paste it here. The address is this, and paste it there, and check if the formula is unmodified. So we got the answer is this. Copy this and paste it here, submit the application, and modify our readme file. So the answer is this. Okay, and this is, let's move to the task 8, OverFlow 7. What's the mission? What's the OverFlow 7? What's the bed chart for the OverFlow 7? Let's start the application, and run it again, modify our pushing to using the OverFlow 7, and clear, run it our pushing here, modify our exploit to OverFlow 7. This will generate a pattern, so open the pattern and remove this char, comment it out, and see its pushing was complete. Still running, to set to 0. Don't forget to reset it, and after that we got a distance of 4,000 here. Run a Mona, start the application to send the payload, run it, then run the exploit, copy this, and paste that, and find the offset. We found the 1306. Let's modify the answer with 1006 03 1306. Okay, and modify our payload to 1306, and set the return address to BBB B, and open here comment is, and beds are set to 00, and let's generate our bed chart. I'm gonna to set the binary byte array, and restart the application, run it again, copy our bed chart byte to the our exploit, and try to run our exploit, and compare the byte array using the address of this byte array. find a bed chart, copy the bed chart, and put our bed chart file here. And this is a bed chart, this is a bed chart, and this is affected by, this is a bed chart, this is affected by, this is a bed chart, this is affected by, this is a bed chart, this is affected by. Isn't it? Let's try again. Bed chart affected by, bed chart affected by, bed chart affected by, bed chart affected by. Okay, let's move this and regenerate the byte. Run mona to generate to compare the byte, and restart the application and run it again. After that, copy this. I don't know how to exploit. What I'm doing. And run the exploit again. And compare the monad to the byte ESP address. Okay, let's paste it here, and the address is, copy this one and control V here, and raw byte address unmodified. So we got this for the answer. Let's paste it here, submit, and modify our readme. The answer is here. Move to the task 9, OverFlow 8, and right on the readme file. What's the IP of OverFlow 8? What's the in order? Let's copy this. And let's modify our payload with bed chart. Here is 00 null byte, and buzzing to the OverFlow egg with the exploit to the OverFlow egg. This is 0. This is empty. I think I need smoke here. And copying out this and out this, and start the machine. And run it again. Okay, application was running, and try to pushing it. Let's clear and try to pushing the application, so I got smoke when this pushing. Sending byte along the byte send. After this crash, then okay, 1000 megahertz with distance. So let's start this and run it again and try to exploit. Copy this and run it on the Mona and find the offset. 17, 89, 84. This is the offset is 178986. 1786. Okay, why am you opening this? Back 1786 and try to use BBB, and now we are using a payload. Payload is oh no, wrong terminal. We try to generate our bed chart. Our bed chart was set to 00. Yes, and generate the bed chart. Tell Mona to write a byte array. And start. Run it again. And why you still force script? I need. Okay, and application run, and then let's copy this, set to our payload, and run our payload with the exploit and compare with the ASP. Got the ASP here. Find the bed chart. Copy the bed chart here. And paste to our bed chart text here. This is the bed chart, this is an affected byte, this is a bed chart, this is an affected byte, this is a bed chart, this is an affected byte, this is a bed chart, this is an affected byte. Save it, try to generate it again. And tell Mona to use this to generate byte array to compare. Start the application, run it again, our exploit, modify the payload, save, and run the exploit. Copy again the Mona. Paste it again. Look like if the address is one, this address is still the same. Am I correct? Let's copy this, but we are just for view unmodified. So copy the bed address here and paste it to the answering and here, and update our readme. This is 78. Okay, let's move to the task 10. We have to mission again, and what is the overflow 9? In bad order, what is the the bed chart on the overflow? Okay, we need to overflow 9, modify to use the overflow 9's our exploit. Move this Open this, remove this, set to 0 again, and the overflow is overflow 9. So start the application, run, clear, try to fusing it and find the offset. Okay, sending 800 bytes, 900 bytes, 10,000, 1000 bytes. Keep increasing by 100. I will up my script on my GitHub repository and try to restart again. Run it again. So after run, then we need to run the exploit. Make sure the exploit remove the BBB. Okay, open pattern, because the fusing will generate the pattern text here. I'm write this to the pattern, so just run the exploit. On the mission we must copy and paste, like that. So I'm generating this to check to make me easy to fasting to finding the offset. Like the offset is here, 15 and 14. Let's paste it here, 15 and 14, and let's modify our readme. My readme too. Also I will put that to my GitHub repository. You can check my GitHub repository is lodwig. Habis BBB and change this. Our picture start from the null byte and then generate the picture. Then wanna generate picture with the null byte. After that, start the application and running again. On that, we need to copy the byte to our exploit. And save it and try to run the exploit and copy this with the ASP address from the Windows CPU here. Well, look like side 019. After that, if we find the bits are all the bits are, copy to keyboard all the bits are and paste it to our bits are here. And modify. This is a bit chart, this is an affected byte, this is a bit chart, this is an affected byte, this is a bit chart, this is an affected byte. Okay, and generate again the bit charts. Termona again to create a binary to compare. And paste it here. Start the application, run it again. After that, we need to copy our payload to our exploit. Paste paste it here, and then exploit again, and tell Mona if that's 109019, then we have on the right pad. Let's copy this clipboard and paste it here, and that unmodified. Whoa! What we got here? Copy the bed charts again. Let's check it again with the bed charts. Paste it here. This is 3A, this is bed chart. This is look like this, and affected by this is a bed chart. Okay, we should move this, make it this, and try to generate again. Copy this again, and paste it here. Now please generate the bed chart. Start running. Copy it here. Paste it in our bed chart. Run our exploit. Compare the Mona again. This address, wow, this is can be corrupted. What we got here? I hope this running well. Okay, I modified. Define all the bed charts. Why we need to find the bed charts? Because when we generate a payload, the bed charts can be removed, excluding from our payload. That's why we need to find a bed charts on this exploit. On the last mission, if you like my video, don't forget to like it and click the button subscribe there. If you have something, just leave it the comment. Now to the task OverFlow 10. Okay, and let's try to modify. Let's restart this first application here. Start, right again. Try to pushing it again. Now we are on OverFlow 10. Exploit on. Remove this. Open the pattern. Comment this out. Remove this. Set to 0. Change to OverFlow 10. Okay. Clear. And fuzzing. Modify our bed chart to null byte. After fuzzing, we need to restart the application and run it again. After that, we need to exploit, and after exploit, we need to find the distance on Mona to find the offset. 537. Let's paste it here. and modify our readme and change our exploit to using 567 and the offset is BBB and save it and generate the vector, then mono to write the vector, then try to restart and run it again. After run, copy the bytes of vector to our exploit. We need to paste it here and run our exploit. Copy this to Mona with the bad address of ESP. Find bad address here. Copy our bad address here. Beta, not bad address. Sorry, it's a beta. This is a beta. This is affected by. 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 Okay. Try to generate again. Tell Mona to generate this again. And then restart the application. I need to tell Mona to write the new byte array and restart the application. I need to run it again. Copy the vectors generated to our payload and paste it there and then exploit it again. Copy this all and wow, what I'm doing, paste it here. The back address, paste it there and find a vector. If this was unmodified, then we copy all the vectors here as the answer of the OverFlow 10 here and submit, and whoops, we finish the buffer overflow here and modified our payload and save it here. I will leave my exploit here to generate the XX here. Try to modify this, change this to machine IP. Change here for task. Our start task 1, offset is 0 and BBB is 0 and payload is here. This window cell to make you sure this, I will remove this big window cell here. You see the pattern. Okay, pushing. I will try to override this. And make some scripts, change this to machine IP, change this to task, okay, then a little better. Okay, all done. And CD, I will try to give error of this, give commit, adding a few room. Need to ask the message here. And git push. On this video you have a file inclusion readme and scan it too on my here on my GitHub repository. Okay, thank you for watching me and for supporting me. If you like, please let me know in the comment. And I will still to continue to live. I think we need to rest about 1 to 2 hours, and then I will try to live and get on the mission, on the TryHackMe mission. I don't know let's terminate this. Let's maybe in the new box here, I don't know. Just keep watching me. This is a new kitty here, or we go to reverse engineering chat program here, or kitty, or file inclusion was including my GitHub. But I said still not doing that. And thank you for watching, and see you again. Bye.